Welcome. In a previous video, I showed you guys how to solve a system of ODEs using the exponential matrix in the homogeneous situation. Today, we're going to be dealing with the non-homogeneous situation, which is exactly what we have here in the P. When f is not the zero vector. So how do we do that, and how do we use this exponential matrix that we've learned in the previous video? Well, let's go ahead and take a look at what we want to solve. We want to solve the system of ODEs. Well, let's go ahead and pretend this is not a vector. Let's go ahead and pretend a is a constant. That's not a vector, and that's not a vector. It's just a function. Well, back in the day, we would move this over to the left, and we would use the integrating factor. What would be the integrating factor in that situation? Well, it would be e to the antiderivative of what is here. And what is there? Well, it's negative a. And the antiderivative would be negative at. The next step would be to multiply this from the left. So, or in that situation, it really would not matter. But let's go ahead and turn these back into vectors. And let's go ahead and let a be a matrix. So now we can worry about multiplying this, the exponential matrix, to the system of ODEs. So it is important which way you multiply this. We want to multiply from the left. So if we do this, if we multiply from the left, so let's go ahead and do that here. Scoot this over a little bit to the right. We're going to have e to the negative at, e to the negative a. So doing this, we're going to get e to the negative at times the derivative of x minus e to the negative at times a times x is equal e to the negative at times f of t. Well, we would want to switch these two around. And the reason for this is that the derivative of this matrix is going to be negative a e to the negative at. And normally you cannot commute matrices in general. Nonetheless, you can do these with these particular matrices. And the reason for this is just take a look at the definition of e to the negative at. Well, it's the Taylor series. You plug in, I'll just go ahead and we have it up here, already written for you guys. Remember, we're plugging in a into this Taylor series, and when you multiply by a on the left, it doesn't matter. You can distribute it here, but then you can always pull one out from here, and then so you have an a on either side. So we can do that. We can then collapse this entire piece to the derivative with respect to t of e to the negative at times vector x. On the right, we're going to get e to the negative atf of t. We then take the derivative, and what we're going to be getting is what we have here, but with an integral on the right plus a constant vector. What in the world? How do you integrate a matrix term by term? Remember, we defined the derivative of a matrix term by term, so we're going to be integrating term by term. Afterwards, what we're going to be doing is we want to solve for x. So we multiply by the inverse of our matrix on the left. And if you do that, you're going to get this here. Some of you guys are interested in knowing why this is the inverse of that there. All you have to do is you got to multiply them together and show that what you get is the identity. That's not a problem. We use the property that if you have two matrices, A, B, which commute, then you have that these two is the same thing as adding them up. So using that, we can show that this is the inverse of the left. So this is actually the system. We're missing something here. When we multiply this, we also want to multiply it on the right. And so we have e to the at. So let's go ahead and box this in pink. And this is the solution to the system of ODEs, of the non-homogeneous situation. How do we actually apply this to an actual problem? Well, let's go ahead and go down to this problem right here. Let's go ahead and paste what we know, and what we know is that this is the answer. Well, you're going to need the exponential matrix. To do that, you're going to need the eigenvalues and eigenvectors, and like in a previous video, you can repeat that process. And if you recognize this matrix, that is because that's the matrix we did in a previous video. And in that previous video, we showed that this here is what you get. E to the TA is equal to this matrix on the right. So now, what you need to do is you need to plug this into this crazy equation and just finish multiplying out. So what's going to give you some trouble if you're unfamiliar with this is this portion here. This, you just copy this matrix here and paste it there, and you also paste it right here. What you're going to get here in the box is a vector, and you're just going to multiply it at the end and add it to the part on the right. So this is where I want to focus in on, is what does this actually mean? So let's go ahead and write this out here, and let's see what f of t is in this particular problem. In this particular problem, it's going to be on what we have on the far right. So I'm going to go ahead and copy paste it, copy paste, and then what we need here is our matrix, and I'll just go ahead for simplicity, just write e to the negative at. This is what we want to multiply together. So if we do that, what we're going to be getting is, first of all, let me go ahead and just pull out the half from e to the negative at, and let's go ahead and focus on this. So what we're doing here is we're adding, this here tells us that we're adding column 1 and column 2 with this weight to all of it. So all we need to do is just add these two together, and if you notice, if you add them, you're going to get that these two cancel. You're also going to get that these cancel. You're going to get twice this amount, this and this. So we're going to get 2 times e to the 4t, and at the bottom twice e to the 4t. Okay, so then we also have a half from this that we need to consider, so I'll go ahead and put it down here. So then you go ahead and multiply this out, or you're going to get a half, and you're going to get e to the 4t and e to the 4t. Now, I purposely waited to multiply e to the negative 3. I can easily bring it over here, copy, paste, copy, paste. Nice. So then, what we're going to be getting, we have a half, e to the t, e to the t, and there you go. Now, all we need to do is now integrate. So we're integrating with respect to t. So we're going to be getting a half. It's just a constant, and it's term by term, and what we get is e to the t, e to the t. Nice. So that is what we'll be going. So let me go ahead and copy and paste this here. Delete that, paste that there. Nice. So then we add this up here, erase this here, bring this over, and this is exactly what we wanted. So now for your final answer, you can go ahead and multiply this matrix with this vector, add it up with the other vector, and you're going to get the general solution. Awesome. Cool. Thank you for joining.